Welcome back, trigonometry. This is lesson 55, circular and distinguishable permutations. It's actually two different topics here. The first one being circular permutations. Those are permutations that take place literally in some kind of a circular setup. And then distinguishable permutations means that they are unique permutations from each other. They are different. So the first type of example we're looking at is a circular permutations. The type of question you would be asked is, how many distinguishable ways can three people be seated around a circular table? So if I take a possible scenario here with person 1, person 2, person 3, and then I also rearrange it to say, well, if person 3 stays in the middle, but we just switch where person 2 and person 1 are sitting, that would be yet a different way, and therefore there are only two ways to seat three people in that circular table. Now that would be fine to draw out examples if we only have a couple of people sitting down, but if we have more than, say, 5 people, it becomes rather tedious to write that all out. So the formula that you need to focus in on for this is that we take our normal factorial, that's the exclamation at the end, and we subtract 1. So in this case, if there are 3 people, we would take 3 minus 1, get 2, and do 2 factorial. All right, so that is the shortcut formula for it. Here we have example 2. How many distinguishable ways can 4 people be seated around a circular table? And we again can draw this out to determine there are 6 different table setups that would allow for a different way of those people seated around a table. Now notice we don't talk about if they were rotated as being a distinguishable table setting. All of these examples here show A sitting at the north point of the table and then just rearranging B, C, and D in different spots. Okay, so we didn't ask what the difference would be if we could rotate the people because that would not be distinguishable. The layout's the same, it's just a different perspective. So again, I'm going to look at the formula in minus 1 factorial. And because there are 4 people, I plug in 4. It's really just 3 factorial that I'm solving for. All right, and then you're going to notice that distinguishable permutations that we come up to in question B are ones that we have tried together in class before. So let's look at question A for a moment. How many ways can 6 different items be rearranged in a line? How many arrangements in a circle? So the first question is for a line. And what that means is if we had 6 spots available, how many different ways could I arrange those 6 different items? And that would simply be 6, 5, 4 being multiplied all the way down to 1, or 6 factorial. 6 factorial is equal to 720. So that's my first solution. Okay, but if it's in a circle, we use the other formula, which says you would take 6 minus 1 and factorial. So that would be 5 factorial, which is 120. So based on the fact that it's in a circle, there are fewer distinguishable permutations. Question B, find the number of distinguishable permutations of these letters. Now, where this comes into that distinguishable word, it means sometimes we have letters repeated in a word. And so for question 1, the word Miami has 5 letters, so we put 5 on the top of our fraction, 5 factorial. But we go back and we find that there are repeats of the I, 2 of them, and there are repeats of the M, 2 of them. And so we have to divide by both repetitions factorial. So in this case, 5 factorial divided by 2 factorial, 2 factorial. And you can use your calculator or you can write that out. I'll show you here one time how we have it written out. And show how you can indeed cancel and reduce, so that we end up just needing to multiply 5 times 2 times 3, which is 30. For part 2, we're using the word Tallahassee. We first need to count up all the letters of Tallahassee. And that comes up to 11. So that's our numerator with the factorial. And then we look for all repetitions. So the first repetition is an A. And it appears that I have 3 sets of A's, so I'm going to have a 3 factorial in my denominator. The next repetition would be L. 2 sets of L's, so that's going to be 2 factorial. Look for any other repetitions. We have S repeated twice and E repeated twice. That takes care of our repetitions. And then we are going to simplify that. This is one that I would highly recommend a calculator to help you with that factorial simplification because we're looking at 6-digit number for our answer. So we get 831,600. Then please just try that on your calculator. Make sure you come to that same conclusion so that you know how to do it on your own. Looking at question C, Jimmy has 10 marbles. 3 are red, 3 are blue, 4 are green. How many distinguishable permutations of those 10 marbles can he form? Think of this as the word Miami and how there are some repetitions. So we first start off with the whole amount of marbles, which is 10. And that will be my numerator. And then I'm going to write below it all the repetitions. So we were told 3 factorial, 3 factorial, and 4 factorial for the 3 red, 3 blue, and 4 green. Calculate that to find the simplified answer of 4,200. All right, next we're going to look into your homework problems. And this is going to be from lesson 55. We're going to do the highlighted questions. It looks like we have questions 1, 2, and 3 that we'll be doing together. In your book, let's get over to page 365. On page 365, question number 1, how many distinguishable ways can 3 white marbles, 3 red marbles be placed in a row if 2 marbles of the same color cannot be adjacent? Okay, so we have 3 white and 3 red marbles. I'm going to make that note up here. And I'm going to show you how we could possibly just draw this out. We aren't allowed to have any of those marbles touching each other. So if I start with a white marble, and I have 6 total marbles when I add them together, that would be white, red, white, red, white, red. That takes care of all 6 marbles. But I could have also started with the red marble, so that would just go opposite order, red, white, red, white, red, white. There is really no other way that I could lay this out and have unique marbles next to each other. So that means there are only 2 ways that that would work. And this is better suited by drawing it out. For question 2, the king, queen, duke, and duchess dined at a circular table. How many seating arrangements were possible? So we have a king, queen, duke, and duchess. That means we have 4 seated. And it's a circular table, so that means we're going to take n minus 1 factorial. So in this case, 4 minus 1 factorial, which is 3 factorial. 3 times 2 times 1. And that means my answer will be 6 different ways that you can seat those 4 people. Going to question 3. How many distinguishable permutations can be formed from the letters in the word aberrant? Okay, so the word is spelled A-B-E-R-R-A-N-T. First, you're going to count up all the letters in that word, aberrant, and I say I have 8 letters. So my numerator is going to be 8 factorial. Then I go back and find any duplications of letters in the words. and I have two A's, so I'll make that a 2 factorial. I also have two R's. Those are the only repeats that I have, so I'm ready to go ahead and simplify that. 8 factorial divided by 2 factorial, 2 factorial, and I get 10,080 as my final answer. All right, and then you should have 3 more questions on your own for this homework assignment. Good luck.